Hello friends, today I am going to solve Uttar Pradesh PGT Physics lecturer exam which was held in 2021, and this video is going to be helpful for PGT aspirants and MSc Entrance candidates as well. So this is part 1 video. So without any delay, let's start guys. Question 1. Two coherent sources of intensity ratio 100:1 interfere. The ratio of intensity between maxima and minima is. So intensity ratio is given 100:1. Then their amplitude ratio is, just take the square root of that intensity, so 10:1. For maxima, add the amplitude and square it, and for minima, subtract their amplitude and square. 10 plus 1 whole square divided by 10 minus 1 ka whole square, that implies I max divided by I min equal to 121:81. Option D is correct. Question 2. The radius of the orbit of a satellite is 16 times the radius of the orbit of a geostationary satellite. The period of the satellite is. These are three Kepler's law. Kepler's law 1, orbit is ellipse. Second, equal area in equal time, aerial velocity is conserved or constant. And third, time period square proportional to radius of the orbit cube. Use third law of Kepler's and solve this question. So T square proportional to A cube. So T2 divided by T1 equal to A2 by A1 whole power 3 by 2. A2 by A1 ratio is given 16 times, then 16 by 1. First square root, then 4 raised to power 3, then 64. And time period of geostationary satellite is 1 day or 24 hours. So T2 equal to this 64 multiplied by 1 day equal to 64 days. Option C is correct here. Question 3. Which of the following is path dependent? So path dependent is PdV. This is the work done, and work done is a path dependent function. Option B is correct here. Question 4. The potential energy Ux of a particle executing simple harmonic motion is. So simple harmonic motion potential equal to 1 by 2 kx square of this form. So option C is correct here. Ux is equal to 1 by 2 kx minus a whole square. Question 5. What is the capacitance of the earth if it is assumed to be a spherical conductor of radius 6400 km? Spherical conductor. So this is our earth. Let's say it is a spherical conductor. Then opposite charges will induced at very long distance, and find the potential for that. So Q divided by 4 pi epsilon naught 1 by r minus 1 by infinity. From here we will get V, and capacitance C equal to Q by V. So C equal to 4 pi epsilon naught r. Put the value of r equal to 6400 km. Convert it in the meter, 6.4 into 10 to the power 6 meter, and 4 pi epsilon naught value equal to, put 1 divided by 9 into 10 to the power 9 and solve it. Option A is correct, 711 microfarad. The numerical aperture of a microscope is given by, it is given by mu sin I. Mu is refractive index here. Question 7 was removed from final answer key. Question 8. 8 equal drops of water are falling through air with a steady velocity of 5 cm per second. If the drops collapses, what will be the new terminal velocity? Similar question was also asked in UP Polytechnic 2022 examinations. This question here it is asking for new terminal velocity. First, find out their radius ratio. Let's initial droplets has radius r1. So 8 droplets come together to make a bigger drop. Then 8 into volume of one drop, 4 by 3 pi r1 cube equal to some bigger drop having radius r2. So 4 by 3 pi r2 cube. R2 divided by R1 equal to 2 from here. Now terminal velocity is defined by this formula. So take the terminal velocity ratio, V2 divided by V1 equal to, almost all other things are going to be same because drops is the same, of same material, same density, same thing. Okay. So only R is changed here. So R2 divided by R1 whole square. So 2 square. So V2 equal to 4 times of V1. V1 value is given, it was 5 cm per second. Put here 5 cm per second. Then new terminal velocity V2 equal to 20 cm per second. Option C is correct here. Question 9. The instrument used to measure optical rotation is known as. A polarimeter is a scientific instrument used to measure the angle of rotation caused by passing polarized light through an optically active substance. Option C is correct here. Question 10. If a resultant R of two vectors P and Q is such that R square equal to P square plus Q square, the angle between vector P and Q is. It is very simple, just use the Pythagoras theorem. So, angle between them is 90 degree. Question 11. The source of solar energy is. The source of solar energy is nuclear fusion. Deuterium and tritium come together to make helium atom. This is helium atom, and along with helium there is also production of neutron. So, this is fusion reaction. So, option C is correct here, nuclear fusion reactions. Question 12. 20 grams of ice at 0 degrees Celsius melts to water at 0 degrees Celsius. The entropy change in this process is. Latent heat is given 80 calorie per gram. So, heat absorbed delta Q is equal to m into L. L is latent heat. Mass is 20 gram, so 20 into 80 calorie per gram, so 1600 calorie. Now, entropy change ds is equal to delta Q divided by T. So, 1600 calorie divided by, it is 0 degrees Celsius, convert it in Kelvin, so 273 Kelvin, and just solve it. So, it is going to be 5.86 calorie per Kelvin. So, 1 calorie equal to 4.2 joule. After putting this value, 24.6 joule per Kelvin. Option A is correct here. Question 13. The electric potential due to dipole P at point distance r from it and in the direction theta from the dipole is. So, option A is correct. 1 upon 4 pi epsilon naught P cos theta divided by r square. Question 14. The gravitational field due to a mass distribution is given by E equal to k x raised to power minus 3 by 2 in x direction, where k is a positive constant. Taking gravitational potential to be 0 at infinity, its value at a distance x is. Use this formula E equal to minus del V. For one dimension, E equal to minus dV by dx, where V is the potential. So, V equal to, just take the integration of this E dx and put the value of E from here, kx raised to power minus 3 by 2, do integration, and answer is 2k divided by square root x. Option B is correct here. Integration formula, you can use this integration formula for solving this. Question 15. If the focal length of objective lens is increased, then magnifying power of. It is asking for microscope and telescope. The formula for magnifying power in case of microscope is given by this LD divided by F0 Fe, and in telescope it is F0 by Fe. So, it is saying that focal length of objective lens F0 is increased. If F0 is increased, then magnifying power of telescope is going to be increased, but for microscope it is going to be reduced. So, option D is correct. Microscope will decrease, but that of telescope will increase, because F0 is on top here and it is in denominator here. So, option D is correct here. Question 16. An adiabatic process is also known as. It is known as isoentropic. Delta Q is going to be 0 here. So, there is no change in entropy, that is why it is also known as isoentropic. Question 17. Fiber optics works on the principle of. It works on the principle of total internal reflection. This is fiber optic. You can send light from one position to other position with this optical fiber. This core is highly reflective, and due to total internal reflection, we can get light from one end to another end. Option B is correct here. Question 18. The internal radius of a 1 meter long resonance tube is 3 cm. With a tuning fork of frequency 2000 Hz, the first resonating position is 4.6 cm and the second resonating position is 14.0 cm. Speed of sound at the room temperature is. Use the formula length plus end correction equal to 2n minus 1 lambda by 4. The first resonating condition, put n equal to 0, so it is lambda by 4. Lambda by 4 equal to L1 plus E, and for second resonating put n equal to 2, 3 lambda by 4 equal to L2 plus E. Take the difference, then 3 lambda by 4 minus lambda by 4 equal to 14.0 minus 4.6. That implies lambda equal to 9.4 multiplied by 2 equal to 18.8 centimeter. Now speed of sound equal to frequency multiplied by wavelength. Wavelength we already calculated here, and frequency is given 2000 hertz. So 2000 hertz multiplied by 18.8 centimeter, convert it in meter. So 18.8 into 10 to the power minus 2 meter equal to 376 meter per second. Option B is correct here. Question 19. For incidence at Brister's angle, the angle between reflected and refracted rays. If light is incident at Brister angle, reflected light is polarized. So this is reflected light and this is refracted light, and angle between them is 90 degree. Option B is correct here, and sometimes question based on this also can be asked. So tan polarizing angle or Brister angle equal to refractive index. Question 20. The peak voltage is 240 volt AC source is. So this is RMS value. Okay. For V maximum or peak voltage, square root 2 multiplied by Vrms. Vrms is given 240. Square root 2 multiplied by 240 equal to 340 volt. Option C is correct. So this is the peak voltage from here to maximum value. This is the peak voltage. This is the Vrms, 0.707 times of maximum amplitude or peak voltage, and peak to peak voltage is from this position to this position. Question 21. Anderson bridge is used for measurement of. In the Anderson bridge, the unknown inductance is compared to the standard fixed capacitance connected between the two arms of the bridge. It is the Anderson bridge and it is used for self-inductance measurement. Question 22. Torsional couple required to twist a cylinder of length L by 2, radius R and modulus of rigidity eta by one turn will be. So this is the twisting. One end is fixed and from other end we are twisting the cylinder. The twisting couple tau equal to C theta, where C is torsional rigidity, C equal to pi eta R raised to power 4 divided by 2L. Here it is given length equal to L by 2, and we have to rotate it by one turn. So theta is going to be 2 pi and length is L by 2. The twisting couple or torsional couple is going to be pi eta R raised to power 4 divided by 2 into L by 2. In place of L, put L by 2 here, and theta put 2 pi. So answer is going to be 2 pi square eta R raised to power 4 divided by L. Option A is correct. Question 23 was removed from the final answer and I am not going to solve that. Question 24. The light from the sun has maximum intensity for the wavelength of 470 nanometer. Assuming that the surface of the sun emits as a black body, calculate the temperature of the sun. So Wien's constant is given here. So lambda m multiplied by T equal to constant, that constant equal to Wien's constant, this Wien's constant. Put the values. Lambda max is given here 470 to 10 to the power minus 7 centimeter, and it is asking for temperature. So just calculate temperature, and value is 6128 Kelvin. Option C is correct here. Question 25. The ratio of masses of a pion and an electron is about 2. Composition of pion is quark and anti-quark, U and D bar, then it is pi plus, pi 0, this and pi minus, and their masses are, in case of pi plus minus mesons, 139.6 mega electron volt per c square. In the terms of energy it is written here, and for pi 0 it is this. The mass of electron in terms of energy 0.51 mega electron volt per c square. Now take the ratio of pion mass and electron mass. So this is around 270. Option A is correct here. Question 26. Mark the wrong statement. To characteristic X-rays, just use this formula and find out. The characteristic X-rays from substances of higher atomic number are longer wavelength than those of the lower atomic number. So this is atomic number Z here. If it is higher, then lambda is going to be smaller, shorter, and for lower atomic number this is going to be higher. So option B is wrong here. Question 27. An achromatic combination of two thin lenses of focal length f1 and f2 is achieved if separation between them is equal to. If you are using single lens, then there is a problem of chromatism. This is for single lens. So a lens will not focus different colors in exactly the same place because focal length is a function of refraction and the index of refraction for blue light is greater than that of the red light. It will be focused earlier. Okay. To overcome this problem, this combination of lenses is used. Different combinations also possible. Here for this case, just f1 and f2 are used. So D should be half times f1 plus f2. Option B is correct here. Question 28. A tuning fork of frequency 260 Hz is vibrated with a sonometer wire and 5 beats are heard. If the tension in the wire is slightly increased, the beat frequency also increases. The original frequency of the sonometer is. The sonometer and a tuning fork both together, frequency differences of them. Let's sonometer frequency is f2, then f2 minus f1 equal to plus minus 5. Their frequency difference we listen or heard is a bits. It is 5 bits. Then it is plus minus 5. f2 minus f1 equal to plus minus 5. So f2 is going to be 260. Tuning fork frequency is given 260 Hz to 260 plus minus 5 Hz. So this is tuning fork and this is for the sonometer. So it can be either 265 or 255. Either this or this. Only one is correct. When tension of sonometer wire slightly increased, f2 increased. So this is either this one or this one. So beat frequency is reducing, then lower one is correct. If beat frequency is increasing, then upper one is correct. So case 1 beat frequency also increased, to upper one 265 Hz is correct. If beat frequency reduces, then 255, this one is correct. Okay, here it is saying that if the tension in the wire is slightly increased, the beat frequency also increases. Beat frequency increases, that means upper one is correct. 265 Hz is the original frequency of sonometer. Option A is correct. Question 29. A coil having inductance 0.15 Henry and resistance 15 ohm is connected across a 220 volt 50 Hz line. Compute the current in the coil. XL equal to 2 pi FL. L is given here, inductance 0.15 Henry. So it is 47.1 ohm. Calculate impedance. Z equal to square root XL square plus R square and value is 49.43. Current equal to voltage divided by the impedance. V is given here 220 volt divided by this impedance value. So current is 4.45 ampere. Option A is correct. Question 30. A cube of aluminium of side 10 cm is subjected to a shearing force of 100 Newton. The top surface of the cube is displaced by 0.01 cm with respect to bottom. The value of modulus of rigidity is. So this is the condition. So top surface is moved by 0.01 cm. Then shearing strength theta almost equal to tan theta because angle is very small. So 0.01 divided by 10 equal to 0.001. Then modulus of rigidity equal to shearing stress divided by shearing strength. So shearing stress equal to this F by A. Shearing force is 100 Newton divided by area. So one side is 10 cm. So just find out the area. So 10 into 10 to power minus 2 meter whole power 2 and value is going to be 10 to power 7 Newton per meter square. Option C is correct here. Question 31. If R0 is the radius of the first Bohr orbit in a hydrogen atom, the radius of the fourth orbit is given by. So this is the formula for Bohr radius, 4 pi epsilon naught n square h cut square divided by mass e raised to power 2 z atomic number, and putting all constant values it is equal to 0.529 n square divided by z angstrom. N1 it is given R0 and it is asking for R4. So R4 divided by R1 is going to be 4 square divided by 1 square equal to 16. R4 equal to 16 times this R0. Option A is correct here. Question 32. Potential energy per unit volume U of a strained wire is. So it is U equal to half stress into strain energy per unit volume. Okay, so this is the correct option C, and similar question was also asked in Chhattisgarh CGPSC 2020 assistant professor exam. Pattern of CGPSC are almost same level, so you can also visit that paper. It is already uploaded in the assistant professor playlist. You can find that video. Question 33. Two lenses have dispersive power in ratio 2:3. These glasses are used to make a chromatic lens of focal length 20 cm. The value of focal lengths of two lenses are. So dispersive power proportional to 1 upon mu minus 1. It is refractive index of the glass and proportional to focal length. So omega 1 divided by omega 2, it is given as dispersive power ratio 2:3. So just put it. So 2 by 3 equal to minus f1 divided by f2. So f2 equal to minus 3 f1 divided by 2. Now use the formula power equal to p1 plus p2 equal to 1 upon f equal to 1 upon f1 plus 1 upon f2. Put the values. Final focal length is 20 cm. So 1 divided by 20 equal to 1 upon f1, and in place of f2 put this value and solve it. So f1 is going to be 6.67 cm and f2 putting value f1 here to minus 10 cm. Option C is correct here. Question 34. A capacitor with air between its plates has a capacitance of 8 microfarad. If its capacitance on introducing a dielectric with dielectric constant 6 between its plates is. So capacitance of air capacitor is given 8 microfarad, epsilon naught A divided by D. When we are introducing dielectric in between that, then formula is C equal to K epsilon naught A divided by D. This value is 8 microfarad and K is 6. So 6 into 8 equal to 48 microfarad. Option A is correct here. Question 35. For a van der Waals gas, the inversion temperature at low pressure is. The inversion temperature at low pressure is going to be 2A divided by RB. Option D is correct here. Question 36. The wavelength of K alpha X-ray line of an element of atomic number Z equal to 11 is lambda. The wavelength of K alpha X-ray line of another element of atomic number Z is 4 lambda. Then Z is. Use this particular formula, 1 by lambda proportional to Z minus 1 whole square. Then calculate it. Lambda 2 by lambda 1 equal to Z1 minus 1 whole square divided by Z2 minus 1 ka whole square. Other value is going to be cancel out. So just solve it. So lambda 2 is given 4 lambda and lambda 1 is lambda put here, and Z already given here Z1 11. It is asking for Z2. Z2 is going to be 6. Option C is correct here. Question 37. The ratio of most probable speed and average speed of a gas enclosed in a vessel is. The value of most probable speed is square root 2 RT by m, average speed square root 8 RT divided by pi m, and RMS speed is square root 3 RT by m, and this ratio is given here. It is asking for most probable speed and average speed. Calculate it. So Vmp divided by V average equal to this divided by this. It is going to be square root pi divided by 2. Option C is correct here. Question 38. A rectangular glass plate of refractive index 1.5 is used as a polarizer. The corresponding polarizing angle will be. So mu equal to tan polarizing angle. Use this formula. So theta p is equal to tan inverse 1.5 equal to 56.3 degree. Option C is correct here, and similar question was also asked in CGPSC Assistant Professor 2020 exams. Question 39. When the plate voltage applied to a diode valve is changed from 48 volt to 50 volt, the plate current increases from 60 milliampere to 70 milliampere. What is the dynamic plate resistance of the diode? The dynamic plate resistance Rp equal to delta Vp divided by delta Ip. 50 minus 48 divided by 70 minus 60, and it is going to be 200 ohm. Option A is correct here. Question 40. Viscosity of a gas is due to transport of. Viscosity, it is due to the transport of momentum. Viscosity results from the jumping of molecules from one layer of a gas to another. This means that viscosity of a gas is caused by the transfer of momentum from one gas molecule to another. And other physical phenomena, heat conduction, transport quantity is energy, and molecular diffusion, transport quantity is mass, and for viscosity it is momentum. Okay, so this was the first video guys. Next part will come soon depending on your response, and please guys like, comment, subscribe. Okay guys, and on daily basis I am putting 2 questions, one is from physics and one is from general. This physics question is going to be helpful for you. You can visit the community tab or section. You can visit and solve that question as well. That is going to be very helpful for your preparation. Okay guys, good luck. Bye bye.